Now for something very important, very skilled, very mandatory, and for something that is called a key. If you had no idea about it, you have no idea about IPv4. Seriously, and that would be a subnet mask, the mask that someone can wear. Let me tell you something. Whether you were going to a masquerade party or you're playing or whatever, usually the concept of wearing a mask is to hide your characteristics, or is to hide or your boundaries, not being your boundaries by like where you start or where you end in that way, but it hides your correct detail, your identifying details, okay, not characteristics or boundaries or whatever, your identifying details. This is the idea. So when you wear that mask, this is what happens. In IPv4 it's reversed. The concept is reversed, because what I will do, or what we all need to do, is that we need to give this IP address a mask that shows its identifying details. Without the mask, an IP address is a numerical value that is valueless. It's a number that has no value. It's a number that I can make no use of. It's a number that when I look to it, I say, and what? I can make nothing use of that, because I can't use it in no device in the world at all. No exceptions is programmed or manufactured to understand this number without its mask. Why? Let me tell you something important, and that would be the guy of the shop, the boring story, connecting 6 computers together, giving an IP address. How did that guy give IP addresses to these 6 computers so that this guy guaranteed at that time these 6 computers will be able to communicate or will be in the same domain? Do you remember when I told you about the network domain and broadcast domain? Meaning that all of the computers can hear whatever I'm saying. This is the idea. Others so far away in another domains will never hear me because they are on another domain. So let me just stick with my domain, right? I'm sorry for that pain. Let me just stick with my domain right now, so that I would make sure and guarantee that those other 5 guys sitting in this room right now with me, all of them really participating in my domain. All of them are really understanding what I'm saying, hearing me well, and if they said anything in return, I will definitely hear them, listen to them in a good way, and I will understand and receive every single packet that they will send. This is the idea. So you can never say, or you can never express an IP address and identify how an IP address really looks like, what are the boundaries and the identifying details of an IP address without its mask, the subnet mask. So it has this naming. Where is my pen? Someone stole that. The subnet mask. So this is the good mask that will reveal the address detail. And what we are going to do today in this video is called subnetting. This is not in the dictionary of English language. This is in the dictionary of the networking world only. So you might find that this is an incorrect word. It's correct in our world, yes. So we are going to do subnetting today. ing, double T-I-N-G. We will do subnet mask, understand the subnet mask, and we will do subnetting. Okay, what I need right now is my whiteboard again. It's a notepad actually. And let me tell you something. If we ever looked at the IP address, that famous one of 192.168.1.1, whatever, this is nothing, because just because you know that an IP address can range from all zeros with all the billions of possibilities to all 255s. What does that mean? That means that this IP address is correct. As an IP address, it's correct. This IP address is correct. This IP address is correct. This one is correct. This one is correct. All of them are correct IP addresses. All of them have no issues. My question is, which one of those, which two or more, participates in the same domain? That is the catch. Which two or more of these 5 addresses participate in the same broadcast domain? So if I used these addresses for the computers, real computers, these computers will eventually in the end be able to communicate together because they participate, their addresses, their ears and mouths participate in the same broadcast domain, so they will be able to communicate. How can I know? Can I guess? Can I ask a developer? No. You will need to know the subnet mask, not the subnet mask of every single one of these addresses, so that when you know the subnet mask, you will know the identifying details of every address. And when you know the identifying details of every single address of these, you will finally know something important, and that is called the boundaries and the broadcast domain of this specific IP address. The broadcast domain will show you the first and the last IP address that participates in the same broadcast domain together, so that whatever IP addresses are between that range, between them, all of these IP addresses belongs to the same broadcast domain. So definitely, all of these IP addresses can communicate together. How can I know that? By knowing the subnet mask. So now let's make this formal, let's make this official, and let me tell you the identification of a subnet mask. A subnet mask is a numerical value that is written by using the values, the binary values of ones and zeros, and the organization of that, or the structure of a subnet mask is to write a set of ones followed on the right side only by a set of zeros, as to never ever in the future to see another ones after those zeros. So once you have your first zero written, all their numbers, numerical values on the right side will definitely be zeros, and all the ones on the left side are ones. In the end, combining or summarizing all of these values together will show you one numerical value, a real decimal value that represents the subnet mask. But it will always have the same size of the IP address, which is 32-bit. So again, an IP address has the length of 32-bit, as well as its own subnet mask that identify and clear its own details. This subnet mask also has 32 bits, so a subnet mask is a 32-bit value that is written in both the decimal and the binary language, and it has the length of 32-bit, and it will be written by using a set of ones, binary, and a set of zeros, so that you will never see another ones after the zeros. Let me show you an example for that, and an example would be 32 digit, like 111111. Every 8 values give a dot, because it's representing the same octet of the IP address, and thus 8 bits, because it's 32-bit and equal. A 111111. This is just a random example. This is another dot because these are other 8 values, more 8 values, then I will give a 1, and suddenly I saw some zeros. So I know that because I have reached so far 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 and 24 ones. So these are 24 ones, and I just suddenly saw a 0. This was a random example that my eye saw on the internet. So I saw a 0, then definitely until I reach 32 in total, I will have to continue with zeros. So I had 24 1, and the total must be 32. So I will need 8 zeros to finish that. So 0 0 0 0 0 0 0 and 0. So this is how a subnet mask looks like in binary, and in combined, it should look like slash numbers of ones slash 24, and in decimal you will use the same method of the previous video. All the ones will be converted to like the combination of 1 2 4 8 16 32 64 128. Yeah, it's in the same method of the previous video. Because you have a binary value, you want to convert it to a decimal, then these ones combined will be 255. These ones combined will be 255. These ones combined will be 255. And these zeros combined will be zeros because they are zeros. And that's it. So what I wanted to tell you, that when you see this example over the internet, actually it can be written in 3 different methods. Method number 1 is the binary method, which is this one, all ones and the zeros. Method number 2 is the combination of the ones, and that will be slash 24. Method number 3 will be the decimal, and that will be the combination of these 255. The combination of these 255.255.0, and that's it. This is your very first example of a subnet mask, because someone told you, just told you that, hey, I have a subnet mask, or I've just seen a subnet mask that looks like that. Just it gave you the binary value, and they fled away. 1 minute, okay, leave them to flow away, and we can understand that from these I will only look to the ones part and I will combine it, and I can even convert that to decimal, and I can understand so many things based on that. Like what? Like, start the serious talk. Like, let me tell you an IP address like 192, the same famous one. This looks like 148. 192, 192.168.1.0. Let me say it in that way. And someone told me that this IP address has the subnet mask of 24. Okay, makes sense. Okay, so this is just an info or an example I saw in an exam. So someone just told me that and they left me. The question is, make use of the subnet mask by knowing the boundaries of this IP address, the network domain of this IP address, the beginning and the end of the broadcast domain or the network domain, so that we would know which IP addresses participates in the same broadcast domain. Well, let me tell you something, and that will be step number 1. You told me that this is slash 24, so in binary it's 24 ones. So 1 2 3 4 no, 5 6 7 8. Every 8 I need a dot for the octet. 9 10 11 12 13 14 15 16 17 18 19 20 21 2 3 4 25 6 7 8 29 20 30 31 32. This is how it should looks like. In decimal it looks like these that I told you in the previous video. No problem, I think we are good so far, and okay, we are done. But regarding the boundaries that you asked me for, well, I need some rules, some extra rules. Like what? Like step number 1 will be, how many zeros do we have? Well, we have 24 ones, and we know that the total is 32. So 32 minus 24 ones, you either read that, or you do it by math. Then you have 8 zeros. Okay. Step number 2, this is based on 2 to the power of, just like we have seen, 2 to the power of number. And we have a rule here, says when you want to know the number of hosts that participates in the same broadcast domain, you need a mathematical rule of 2 to the power of the zeros that you have. And that will lead me to 2 to the power of 8, because I have 8 zeros in this subnet mask, and that will equal to 256, if I remember that correctly. 2 to the power of 1 is 2. 4, 8, 16, 32, 64, and 128 to 56. Yes, we'd have it in that way. So 2 to the power of 8 equals to 856. So what does that mean? That means that the amount of hosts, or the amount of IP addresses, all the complete number of IP addresses that participates in the same broadcast domain of this address is 256. This one starts from 192.168.1.0 that they just gave me in the example, and good, it starts with 0 and ends with what? It ends with the last number. So I need to, in the calculator, to type 0 plus 256, because this is the number of the addresses, and the result will be 0 plus 256 is what? Well, actually, it will be 256. No, it will be 255. Why? Because 0 is counted, and I have written that, so I will start counting from 0. So 0, 1, not 1, 2. If you think that this is too much, well, I can tell you something different. Well, we can just assume that 256 minus 1 is equal to 0 plus 256. And I will give you a ton of more examples. But the idea is, since I started counting from 0, then I shifted back one numerical value instead of starting counting from 1. So the last number will be 192.168.1.255. These are the two numerical values that I just want to get out today in this video. This is very important, and you'll have too much examples in the upcoming video. But the idea is, I just knew from knowing the subnet mask value what was the very first IP address in this broadcast domain and what was the last IP address in that broadcast domain. Now let me tell you something extremely important. Both of these IP addresses, you will never use them. You will never use the first one, and you will never use the last one. Why? The first one is called the network ID, and this is an identification representing the network ID. Whenever an IP address belongs to this domain travels the world, when they ask it, I'm sorry, for which network do you belong? I belong to the network of the ID of 192.168.1.0. Step number 1. Step number 2, the last IP address is also you cannot use in your computers, for your computers. This is an important thing, and it's called the broadcast ID. This one cannot be used as well. This one is used whenever you want to communicate the entire broadcast domain at the same time, so you never give that IP address to a computer. So your question will be, are you joking? I need valid IP addresses. Now we come to the rule of valid hosts or valid IP addresses. That rule says the number of the hosts, which was 256, we need to take 2 of it, which is the .0 and the 255, and we will have the result of 254 valid IP addresses belongs to that domain of 192.168.1.0/24, and all of these 254 IP addresses can communicate together. They start from the very first IP address after this one and end at the last IP address before this one. So the first IP address after the .0 will be .1, 192.168.1.1, and we will need .2, .3, .4, .5 until we reach the last IP address before 255, and that will be 192.168.1.254, the very last IP address. Each one of these need its own subnet mask to be written beside it, all of it. So that was just an introduction to what subnetting is. In the upcoming video, we will do 3 different subnetting examples, and we will see what will that lead to. Okay, so I hope that it was clear so far. Otherwise, it will be clear in the upcoming video.